Tiger Data Modernization Toolkit is a set of utilities that will help migrate from a legacy platform to a modern cloud data platform. These utilities are lightweight and can be individually deployed as per need. This utility helps extract database inventory automatically based on the source system metadata. This tool parses queries from source database and reverse engineers the source to target mapping. The tool supports queries, view definitions, stored procedures, etc. We connect to our legacy warehouse and leverage the Discovery utility and SQL parser utility to get the following details in the dashboard: the volume of data that needs to be migrated, the lines of code, an analysis of the object count by different types of objects, the lines of code by different procedures or packages of views, and then also by schema. The second dashboard provides the volume of each schema and the top 10 tables by volume. The third dashboard focuses on the complexity analysis of stored procedures. It parses through the procedures, views, and other database objects to define the logical steps inside the code. For each piece of code, it will define the logical steps inside the code. For instance, the declarative keywords. How many are SQL insert statements? How many lines are related to the exception handling? How many cursors, delete statements, or update statements? Each code is parsed line by line, identifying the logical steps. This helps us derive the complexity analysis for each program. It also gives the other parameters like how many cursors, subqueries, and for loops are there. All these details play major roles in determining the complexity. Fourth dashboard. For example, in one SQL program, we parse it and identify logical chunks within the code. These logical chunks include declarative keywords, SQL statements, and insert statements. Specifically, we find a SQL insert statement that inserts data into a customer's table with hard-coded values. We also identify keywords related to exception handling and other logical groupings within this particular PL SQL program. Once we have established these groupings, the specific query is further parsed to define or re-engineer the source-to-target mapping. This detailed breakdown allows us to understand the complexity of the code and facilitates accurate re-engineering. The fifth dashboard provides a quick analysis of various aspects of the queries. It includes information on how many involve column mapping, how many contain expressions, and the number of tables involved. The dashboard also provides a complexity definition for each particular query and shows different types of aggregations. Custom-built UI will be used to view the lineage, and the STTM, source-to-target mapping, can be extracted too. The STTM will be available in the lineage tool. We can search for a particular table and see the logic involved in populating it. For example, we can track how the customer master, product master, territory master, and sales fact tables all join and load data into the final sales summary. We can even drill down to the column level to examine the data. By clicking on the info, we can see the exact expression used. This provides a searchable UI interface where you can identify and backtrack the data lineage. Using the schema conversion tool, we can connect to the source legacy warehouse and extract all the DDL statements. Then, a Python-based parser will parse through the source DDL statements and will generate the target DDL statements. The query migration tool generates STTM, and from the STTM, we generate the view definitions or procedures as part of the target environment, which is configurable and can be used for any complex scenarios. The data validation tool helps in comparing the data that is migrated from the source to the target. It takes a three-step approach. Step 1, it validates only the count of records in each table. Step 2, profile-based testing for each column. Is there a table for which all the counts have matched? Then we do profile-based testing at each column level. Step 3, sampling-based cell-level validation, using a hashing method to identify if there are any row-level issues. The output is generated into a nice dashboard